Hello, welcome to Cool Science. I'm Jonathan. We're here today in Space Place at Science North, and I'm going to show you the science of exoplanets. Until about 20 years ago, the only planets that we knew for sure existed were the ones in our own solar system. But astronomers had suspected that there must be planets around other stars. They called these exoplanets. In 1992, they made the first confirmed discovery of an exoplanet. Since then, we found hundreds and hundreds more. But how do we discover them? Some exoplanets have been imaged directly with telescopes, but that's not easy to do. A star is very bright, and a planet is very dim. So what you have to do is block out the light of the star in your telescope, and then take a thermal image or measure the temperature of the planet, because it will be a lot brighter with the heat that it's emitting than the light that it's reflecting. Since directly imaging exoplanets with a telescope is such a challenge, it's easier to observe the stars for indirect clues that a planet might be there. And one of those clues is the motion of the star itself. Now in this model, you can see that the star is fixed in the center, with the planets going around it. But really, the star is being pulled on by all of the planet's gravity as well, and so it moves around in a certain pattern because of the planets that's there. So in this model of a solar system, the center of balance is somewhere outside of the star. And that means that as the planet orbits around, the star also orbits around this center of mass. So we'll let it orbit, and we'll see that the star is also moving in a circle. And we can see that motion. But how do we tell that a star is moving? When it's moving towards our telescopes, its light is shifted to a more blue color. And when it's moving away from us, it's shifted to the red. So this red shift and blue shift, these changes in the frequency of the light coming from the star, is probably more familiar to you as the Doppler effect that you've heard with sound. So when the sound is coming towards you, the sound waves are being compressed, and it changes the pitch of the sound, the frequency of the sound you hear. When it's moving away from you, the sound waves are being stretched out, and it lowers the frequency of the sound. So we can hear the motion of the sound just the way we can see the motion of the light of the star. The easiest exoplanets to detect with this method, which we call the wobble method or the radial velocity method, are large planets like Jupiter that are very close to their sun, because the star makes a very big motion that we can detect easily. A smaller planet with less gravity affects the star much less. And so the circle that the star makes is a lot smaller and harder for us to measure in our telescopes. So for small planets, we need to use a different method to find them. The transit method of exoplanet detection uses a telescope to look at the stars and watch for changes in brightness of those stars over time. So if a star has planets, and the orbit of those planets lines up just right with our view from the Earth, then sometimes the planet will cross in front of the star and block some of the light from reaching the Earth, and we'll measure that block in our telescope. This is called a transit, when the planet crosses in front of the star. So if we see a regular pattern in the changing brightness of the star, we can conclude that there must be a planet orbiting around it. And in fact, we can even tell how long it takes the planet to orbit the star by counting the time in between each transit in front of the star. What if the star has more than one planet? Well, we can tell because the graph looks different. We can see that there are two different sizes of planet because they block different amounts of light. And we can tell that they're moving at different speeds because the transits don't happen at the same time. One planet transits more often than the other if it's closer and orbiting more quickly. The real challenge for astronomers is interpreting these brightness graphs to make sense of what's going on in the solar systems. Imagine what a graph of our sun's brightness would look like, with 8 different planets of 8 different sizes going at 8 different speeds. But the results of this work is well worth the effort. Using the transit method, the wobble method, and other methods of detecting planets, astronomers have found, as of September 2014, over 1,800 different exoplanets, and there are more waiting to be found. We estimate that on average, there's one planet for every star in the Milky Way galaxy. And there are over 200 billion stars in our galaxy. Now that means that just about every star you see in the sky could have other planets orbiting around it, other worlds. That's something to think about. when you go and look up at the night sky. This is the science of exoplanets. Thanks for joining me on Cool Science. I'll see you next time.